Hi ladies, it's Mr. O'Sullivan. Today is an edPuzzle lesson. There is no delta math. So today's edPuzzle lesson is all about 5-6a, setting up the Triangle Sum Theorem. We already went over the Triangle Sum Theorem, but we never really put a name to it. So let's put a name to it. Today's learning target is, I can set up the Triangle Sum Theorem by constructing an equation. But before we actually set it up, I want you to complete this do now on edPuzzle. Looking at the two images below, identify one thing that both images have in common and one thing that is different about each image. So basically, what do you see? What do you think? So tell me what's going on between image number 1 and image number 2. So if you answered the do now, you might have said that they are both triangles. And one thing that is different is that in image number 2, this is extended. I have an exterior angle. I have exterior angle at angle number 4. And if you look here, I just have a regular triangle with nothing drawn on the outside. Another thing you might have said is that this one has the angles labeled 1, 2, 3, and 4. Here, I just have semicircles with different colors to show that they're different angles. So this image right here is an example of the Triangle Sum Theorem. And then the image on the right is an example of the exterior angle theorem. Because I have an exterior angle at angle number 4. Right. So let's look at what it means to set up the Triangle Sum Theorem. So the Triangle Sum Theorem states that the sum of the measures of a triangle is 180 degrees. So every single triangle in our class will be 180 degrees. If you take a college level geometry class, you're going to learn that there are some triangles that actually have more than 180 degrees. But for our class in this year and next year and the rest of your high school career, they will only have 180 degrees. So when we set up the Triangle Sum Theorem, we simply take our angles and we add them up and set them equal to 180. So for instance, I would take this angle, and this angle, add them up, and set them equal to 180 degrees. That is all we're doing today to set up the Triangle Sum Theorem. So practice, set up the Triangle Sum Theorem for each of the following images. Again, we are not solving, we are just setting up. We will do the solving tomorrow during Zoom. So in my first image right here, I have 3 interior angles, and my interior angles are 4x plus 9, 7x minus 13, and 2x plus 2. Again, all I'm going to do is take those angles, add them up, and set them equal to 180. So my setup for this problem would be 4x plus 9 plus 7x minus 13 plus 2x plus 2 equals 180. And that would be your final answer. That's all we're doing today. We are just doing some setup. No solve, just setup. Okay? Now let's look at this next example. In this next example, I have 3 interior angles that I'm aware of. I have a 10x minus 4, a 4x minus 22, and an x plus 11. All I'm going to do is take those angles, add them up, and set them equal to 180. So I'm going to do 4x minus 22 plus 10x minus 4 plus x plus 11 equals 180. And that's all we're doing today. No combining like terms, nothing. You can combine your like terms to make this look a little simpler, but again, we're going to focus on that tomorrow. Number 3. We have 3 interior angles. We have the 43, the 103, and the x. So we're going to just do 103 plus x plus 43 equals 180. And you can change the order just as long as these 3 angles are together and you still have them equal to 180. Let's look at this next example. What's different about this example compared to some of the examples we were just doing? What do you notice? What's different about number 4 compared to our other examples? Okay, so with number 4, I have 3 angles. You might say I only have 2 angles, but no, I actually have 3 angles. And what I want you to do is every time you see this little square, that means you have a right angle. So I want you to put a 90 in there to show you that you have 3 angles. So my setup for this one is I have my 3 angles, the 90, the 63, and the x. So I'm going to do 90 plus 63 plus x equals 180. And that would be my setup. Number 5. Again, I have 3 interior angles. I take them, I add them up, and I set them equal to 180. So my setup for this would be x plus 18 plus 112 plus 4x equals 180. And that's my final answer. I have one more. After this, we're done. Wait, no, we have one more question. We have a digging deeper. Okay, so for this one, I do my setup. I have 3 interior angles. I have a 98, 4x plus 9, and a 33. I add them up, and I set them equal to 180. So I have 98 plus 4x plus 9 plus 33 equals 180. Let's go on to our digging deeper. So digging deeper, who is correct? Asala and Yenivel were working on their geometry homework but disagreed on how to approach this problem. So I have an image to the right. Yenivel said that she could not set up the triangle sum theorem for this problem because the triangle only has 2 angles. Asala said that she could set up the triangle sum theorem for this problem because there are 3 angles labeled in the triangle. Who is correct and explain why? So I'm actually going to ask that you do this one on the edPuzzle. So actually write in a few sentences on who is correct and why. I'll give you a few moments. So for this question, Asala is actually correct because I do have 3 angles. This angle right here is 90 degrees. So Asala is correct. Yenivel is incorrect. So Yenivel is just saying that I have 2 angles, 57 and 4x plus 1. Yenivel is not acknowledging this 90-degree angle. So what Asala is saying is that her setup would be 90 plus 4x plus 1 plus 57 is equal to 180. So again, what we were going to be focusing on tomorrow is we're actually going to focus on how to solve this equation and find out the missing information that we want. So ladies, Asala was correct. There is no Delta Math today. It is just the edPuzzle. So once you finish this edPuzzle, hopefully by 5 o'clock so you can get your extra point, you're done with geometry for the day. And if you have any questions, please email myself or Miss Colorundo. Have a great day, ladies.